It can feel like the climate is changing faster than we can react, but there are people doing good work. There is a climate crew.
Blue carbon is carbon stored in marine and coastal systems. Primarily refers to the carbon stored in salt marshes, eelgrass and seagrass systems, and mangroves. Carbon is one of the important building blocks of life. It exists in almost everything, us, the trees around you, bacteria. It also is important in the atmosphere. Carbon dioxide and methane and other gases are part of the reason that the planet is inhabitable. What's happening today is old carbon that has been stored under the surface of the Earth is now being released in excess, creating changes in the climate of the planet today. So there's an increasing awareness of the importance of nature-based solutions or nature-based systems in the whole carbon balance of the planet.
How to measure blue carbon. Map the area and take core samples.
If you want to bring the quadrat back here, just leave the tape there. We can work off the 17-meter mark here. We're going to count how many plants we have, ID them and count their stems. We're going to look at the aerial cover and then we'll measure. In this way we have an idea of what the plant density is. You can see that's probably going to be the highest bulk density of carbon in there.
So the plants with deeper roots are better at carbon storage?
Well, it's part of the carbon pool. So all of these will have a certain amount of carbon in it. So what we want to know is how much carbon is in the plant versus how much carbon is actually in the soil from dead plants or diatoms or algae. So they're all part of what we call the carbon pool.
Carbon pools are areas that take in and release carbon. Next step in measuring blue carbon, take a gas sample from the area.
From studies so far, these salt marshes are taking up 3 or 4 times as much carbon as a forest system and storing it. They're mighty, but they're also small, but per unit area, salt marshes are very effective carbon storage areas. So the gas analyzer is measuring how many greenhouse gases are being produced from the plant and the sediment in the chamber. So what we'll do is we'll calculate what's called flux, how much carbon dioxide and methane is being released, and we also compare it to how much carbon is being stored in the sediment. This gives us an idea of how important these systems are as nature-based solutions to climate change mitigation. It looks like everything now is settled in, so we can save the file and shut this down. And more recently, there's been investigation into the role of kelp and other seaweeds in picking up carbon. It's a science that's more in its infancy. So the work that Jen and her team are doing to map and monitor eelgrass and kelp systems is extremely important for us to understand their role in blue carbon dynamics along the coast of BC.
We use our drones to fly over top of the meadows. It's really important to see, are our kelp forests and seagrass meadows, are they changing over time? Are they getting bigger? If we are starting to potentially lose some of these invaluable habitats, we want to be able to step in and do different actions such as restoration that we can do at these sites.
Flying the drone is fun, but I really like getting in the kelp bed itself as well.
Yeah, it's nice to get your hands wet.
It is.
We set these quadrats randomly across the entire kelp forest and we're able to get an estimate of what the density is. So there's a lot of variability that we do see within these. So that's where we are counting the fronds and understanding how thick this is.
So the bulbs that help the kelp float up to the surface and capture sunlight, are they also important for sequestering carbon?
Potentially that's another place where kelp is storing the carbon in these offshore areas. So there is some research in these 100-meter depths and finding that they are seeing that there's kelp material down there.
So this is pretty new science then.
But yeah, we're learning new things every day and understanding the role of these coastal ecosystems and how they contribute to climate change as well as resiliency to climate change is really essential. And there's going to be a lot of research coming out that's going to be showing how important these habitats are.
That's really cool.
Healthy seagrass meadows and kelp forests are partners in climate change because they protect our coastlines both from increased currents and wave exposure, as well as helping keeping our temperatures cool and our shoreline stable. So really essential to ensure that we have our healthy ecosystems in the future. Only in recent years have we actually seen the value and actually been able to test the value of blue carbon in these ecosystems such as seagrass and kelp and salt marsh.
I've been looking at blue carbon for probably a decade now, and the more we learn, then we just become better stewards for the environment, where we truly understand that interplay between biodiversity, climate, and life as a whole. I have a really personal connection to the coast, to BC. My grandmother's First Nations, so they've been here since the ice left. So just to have that privilege to be able to keep being plugged into the environment and have that connection to the landscape is a special kind of thing that connects to what I do and who I am.
So the work we're doing here in our kelp and eelgrass meadows is really new science, but the local First Nations in this area have been here for thousands of years and have been caretakers and monitor these important ecosystems. So it's also a really important component that we need to include in being able to work together at mitigating and being resilient against climate change. There is no separation between humans and the land. It's all one.